Okay, Math 8. We are going to talk about rational and irrational numbers today. So first we need to identify what a real number is. A real number is the set of rational and irrational numbers. And you should know that all numbers, every number that you know, is a real number. Our second question is, what is a rational number? A rational number is a number that can be expressed as a fraction. Decimal representations of rational numbers either terminate or they repeat. Most numbers and perfect squares are rational numbers. So, we can see that, for example, the perfect square of 25, when I square root it, it equals 5. And can 5 be expressed as a fraction? Of course it can. We can write it as 5 over 1, and that's still 5. Repeating decimals would be something like, for example, if I had the decimal equivalent of 1/3, which is 0.3 repeating. If I have a terminating decimal, that would be like 1/2. When I divide that out, we get 0.5. Or 3/4. When I divide that out, we get 0.75. So those are all examples of rational numbers. They can be written as fractions, they can terminate, or they can repeat. Alright, an irrational number is a number that cannot be expressed as a fraction. Decimal representations of rational numbers never end and never repeat. So these are decimals that go on forever and they never repeat themselves. Which one example of that would be pi. Never ends and never repeats. 3.14159 and then continues on and on. Another example of that would be like a square root of 50. If I type the square root of 50 into my calculator, I get 5.477225557, and it keeps going. It never ends. It's never going to end. It's going to continue on forever, just like pi does. And it's also never going to repeat itself. So square and cube roots that are not perfect squares or perfect cubes are irrational all the time. So if it's not one of those nice neat numbers on your chart, it's going to be an irrational number if it's a square root or a cube root. So we have a table here, and you need to fill in this information that I forgot to put on before I copied. However, we're going to identify each number as rational or irrational. So go ahead and fill those in. The square root of 100. And what does the square root of 100 actually equal? Well, it equals 10. So 10 is rational. It can be written as a fraction 10 over 1. 1089, if we look at our chart, actually equals 33. So it is also rational. The square root of 125. If we look at our chart, we get 11.180 ... It keeps going forever and ever. Since it's not a perfect square, a 10 or a 33, it's 11 point something, it's automatically going to be irrational. The square root of 300, same thing. We get 17.32, so it's irrational. The square root of 900 is 30, so that's rational. The square root of 1500 is 38.72983346. So we have irrational. The cube root of 550 is 8.193212706. Irrational. And the cube root of 2000, 12.5992105, also irrational. So if it's not a perfect square or a perfect cube, it's definitely going to be irrational. Go ahead and turn your paper over. We're going to label each problem rational or irrational, and then we're going to graph the root on the number line. You may want to use a calculator for this rather than your chart, but your chart should work for everything except number 6, which is the cube root of 700. So, first, the square root of 12, you have to ask yourself, is it a perfect square? I can use my calculator. See? The square root of 12 comes out to be 3.464101615, which means it's irrational. And 3.46 is about 3.5, so I would put a dot around 3.5 on my number line. Number 2 is negative square root of 15. Which is negative 3.87, and so on and so on. It never ends and never repeats, so it's an irrational number. And negative 3.87 is almost negative 4. So I'm going to put a point on my number line close to negative 4. Alright, go ahead and try 3 through 12 for homework. You should be able to type these into your calculator quickly and easily, and then graph them. Have a great night.